Welcome to the overview screencast for the data movement topic of the vFabric reference architecture. In this screencast, we will follow this agenda. First, we'll go over the goals of the data movement topic. We will review the simple ETL solution, and we will compare the approach taken within the data movement topic of using a REST API and load balancer to distribute work for our Spring Batch job, and compare that to a message-based approach, which is by far the more supported and prevalent approach within the Spring Batch framework. And then finally, we'll review the remaining batch demos. So first, the goals of our data movement topic. First goal is to implement a simple ETL solution that copies data from the Spring Trader SQLfire data tier to a reporting database, and then be able to bring up a simple report of historical buy and sell orders based on that reporting database. You can see there's a simple image here showing the movement from the SQLfire data tier to a staging database in vPostgres, and then there is a Spring Batch job deployed in a TC server cluster as worker applications that are responsible for copying the data to the reporting database. Our second goal is to demonstrate how we can scale this Spring Batch job horizontally in a TC server cluster so that as the amount of data increases, we can complete our batch job within predefined windows. And then thirdly, we'll highlight some of the Spring Framework tools for building and testing data and REST-based applications, especially some of the new features of 3.2. Our next agenda item is to review the simple ETL solution. We have a diagram that shows the major components and interactions. So our first step is that a DB synchronizer deployed within SQLfire is responsible for copying the orders data from the orders table to a vPostgres staging database. So that's done asynchronously to keep the SQLfire database in sync with staging database. Step 2, we have a command line Spring Batch job launcher that's launched, and will kick off the job, which essentially will start the master process of the job, which is implemented as a master polling partition handler. That will, in step 3, read the data in the staging database and partition it by primary keys into a number of partitions as defined by the partition size parameter. Step 4, the master process will write the partition information to the job repository, and then step 5, for each partition, the job master sends a request to a worker via a load balancer, and the load balancer is responsible for taking each request and distributing it to the cluster of worker nodes deployed as web applications in TC server cluster and implemented by the worker request handler, and there's also a worker controller. So in step 7, the worker application will query the job repository for the partition information that's contained in the request that it received from the master. And in step 8, we'll select that data from the staging database using a JDBC item reader, and then using a JDBC item writer, which is another Spring Batch framework class. It will write the data to the Postgres reporting database. And then at that point in step 10, we have a JQplot graph application that can read the buy and sell orders. One point to make about this implementation is we did choose Spring Batch as a way to implement a simple ETL scenario. Could have also used Spring Integration. That's another option for implementing this kind of scenario. In this case, within the data movement topic, our emphasis was on Spring Batch and demonstrating how to scale Spring Batch and a method for distributing work in a cluster, which is our next agenda item. So next, we're going to talk about the use of the REST API and load balancer to distribute work, compare that to a messaging approach. So the messaging approach is more fully supported by Spring Batch. It assumes that there is a messaging infrastructure in place like RabbitMQ. It interacts with that infrastructure through the Spring integration APIs. And in a typical scenario, the master will partition a step and put multiple step execution requests on the queues. The workers are subscribed to the queue. They perform the step. They respond back via a queue to the master, who waits for all the responses from the workers and then returns a result for that step. And some out-of-the-box implementations within the Spring Batch framework are the message channel partition handler for the master process, and then the step execution request handler for the worker process. So in the REST load balancer implementation provided by the reference architecture, the master is still responsible for partitioning steps, but then for each request, for each step execution request, essentially sends a request via the REST API to a load balancer endpoint. And the load balancer is then responsible for distributing those requests to a cluster of TC server worker applications deployed as Spring MVC apps and managed in the cluster using Hyperic and resource groups. And then the master will pull the job repository for results written by the worker. So in this case, the workers aren't responding with the results of the work directly to the master. They're not responding via the initial request. The workers are writing to the job repository the results of the request, and then the master is polling the job repository, waiting for the status of each step execution to reach a complete status, at which point the master knows that all the step executions have completed. So the reason this approach was taken was to avoid essentially synchronous blocking on HTTP requests, which could likely result in timeouts, especially when you're going through load balancers. So instead, the master sends a request and the worker returns immediately and executes the work in a separate thread pool. So one thing that this assumes is that we're using Spring Batch partitioning, or the claim check pattern in the enterprise integration patterns, and it does not support remote chunking. And the implementations provided by VFRA are the master polling partition handler for the master, and then on the worker side, there's a worker controller and a worker request handler. So if we look at some of the potential benefits of this approach, it avoids the need to deploy messaging infrastructure. So in environments where that's not already deployed, that's definitely a potentially much simpler operational model. There's no need to deploy and maintain a new product. There is no need to implement things like reliable messaging or filtering of responses. And in particular, where there are already load balancers available and deployed, this offers a significantly simpler deployment model for building and deploying scalable Spring Batch jobs. So now we'll talk about some of the trade-offs of using the REST load balancer approach compared to a messaging approach. So big difference here is the use of reliable messaging versus a synchronous HTTP transport. So there's definitely some benefit in a reliable messaging implementation. There's more guarantee that the master request will make it to the worker, eventually at least. There's still the possibility in both cases that you will encounter some sort of timeout situation which will cause a job to fail. Certainly, reliable messaging is quite a bit more complicated to implement. You need to deal with either using a transaction manager to avoid losing messages or getting duplicate messages, or implement some sort of best effort pattern. In addition, if you implement durable messaging, that will add more complication. One thing that can be done with the load balancer approach to improve availability is for the load balancer to implement a heartbeat with the worker nodes to ensure that if a worker node becomes unavailable, it's removed from the cluster and the load balancer is not going to forward requests that will cause failure or partial failure of the job. In the implementation provided, the worker controller implements a REST ping method for this purpose. Another point that could be made is the master process in the load balancer approach is a bit simpler than the messaging implementation. There's no need to implement any kind of message filtering. It's very simple fire and forget requests to the load balancer and polling for responses, and there's no real disadvantage of using a polling method for the job repository versus waiting on a message from a worker. Now we'll take a quick look at the remaining demos or screencasts. We just finished the overview demo. There is also a development environment demo that covers setting up the VFRA batch project in STS or Spring Tool Suite. It also looks at some of the implementation details of the master and worker classes and some of the new Spring 3.2 mock MVC support for integration testing. In addition, there is a batch production overview and scaling demo that covers the setup of the batch environment in vPostgres, Hyperic, and TC Server, and goes through a use case of adding a node to a batch cluster to improve the performance of a batch job. And finally, there's a demo about the batch reporting app and the admin app. Admin app's based on the Spring Batch sample application and is used for operational reporting of batch jobs. The batch reporting app is based on HQplot used by the Spring Trader app. Good example of some of the tools available within the Spring framework for building REST and data-based applications. Uses Spring MVC, Spring Data Repositories, Query DSL, the REST exporter, and the REST shell for testing. Thanks for listening.